Completing the square is a topic that some people find a little bit daunting because the formula, which you might already be able to see here in algebra, looks a little bit complicated. But with these kind of questions, we are just going to be following the exact same steps. So if we do this enough times, hopefully we'll just be able to get into a rhythm of it, doing it by muscle memory. Completing the square itself as a technique can then actually get us a couple of different things. We can use it to work out the turning points of curves, that is to say where they either going from down and up or up and then down, or you can use them to find where it crosses the x-axis, or they can just be used to rewrite quadratics in general. So to start off with, just with the basics, and then as we go through each example, we'll kind of then introduce each other concept. If we're starting with some x squared plus some amount of x plus a number, to be clear, this needs to be one amount of x squared here, while these other b and c can be any numbers. We'll get on to what happens if we do have a different number in front here in a second. If you have this, the completed square form will then be, if you open a bracket, do x, and then half of this middle number here. Close bracket and square. From this, you then minus this halved b here, squared, and then add that number that was there at the end anyway. If we now just use a numerical example, just A, to make it clear what's happening here, and then also just to, again, explain why this is the formula, why we're going to be minusing b over 2 squared, why you're going to halve b in the first place, all that. So if we're starting here, okay, we know we're going to complete the square, so you'll open bracket, but x, and half of this middle number would be plus 2. I'm going to square this, then I'm going to minus this 2 squared, and minus 7. Well, x plus 2 squared, minus 2 squared is 4, so minus 4 minus another 7 is minus 11. That is going to be the completed square form. Again, just for the explanation part, if we were to expand this bracket here, just a different colour, because it's a square bracket at this bracket, then that bracket again. So I think it would just be like a FOIL method. First by first, x times x is going to be x squared. Then x times 2 will be 2x. 2 times x will be 2x. And then 2 times 2 will be 4. So right now, this is what this bracket would expand to. The x squared is the same as the x squared from the beginning. Great. 2x had 2x. That's the 4x from the beginning. Great. And that's also why we wanted to halve that middle number here, because it gets duplicated in the expansion with the square. But here, this gives us an end value of 4. We don't want 4 though, we want minus 7. How do you get from 4 to minus 7? You minus 11. So that's why we want to minus this squared, and then do whatever number was originally. Take away this gets you to 0, and then you carry on as you needed. With this specific example also, we can then also use it to work out when it crosses the x-axis. If we're crossing the x-axis, then y is 0. If this is the equation of the curve, that means the whole thing will equal 0. Just rearranging to make x a subject, you could move 11 over, so it becomes x plus 2 squared equals 11. Again, we wanted to make x a subject, so look at then what's the furthest thing away. That's the squared. So you want to get rid of the squared. You do that by square rooting. When you square root, there is a plus and a minus answer. You want to consider both. You can either write it as this plus minus, one on top of the other, or do it separately as root 11 or minus root 11. And then just to get the x on its own, move the 2, it becomes a minus 2 on the other side, because when you move over the equal sign, the sign changes. So the x, x is minus 2 plus or minus root 11. Those would be the points where it cuts the x-axis. Yes, we could have just factorized this original, or rather put it in the quadratic formula, because, well, we can see if this is going to be the answer, it's not going to be any nice brackets. But yeah, we could have used the quadratic formula to solve this from the beginning, but if either you've had to do the completed square form earlier in the question anyway, or if you just don't particularly like the quadratic formula. This is an alternative method of rearranging to get, again, what the x value will be. If you're okay with that, let's have a go at another example. Here we've got x squared minus 5x plus 9. So again, start with, we'll just do our x. Now, here, half of minus 5 is going to be minus 2.5 squared. Then we're going to minus 2.5 squared, and then add 9. And if we just simplify that, in your calculator, if you were to do minus 2.5 squared add 9, that's going to leave you with plus 2.75. Now this isn't actually going to have solutions to it in the same way that this previous one did. It's not going to cut the x-axis. If we just wanted to check that, if you were to set this as equals 0, move this over, that will become a minus 2.75. If then you wish to square root like we did here, you can't square root a negative number. There'd be an error. What we can do with this, however, is firstly prove that it is always positive. So it's saying, well, no matter what the x value you put in, this answer will always be positive. Well, this squared here means that no matter what the contents of the brackets, it will always be made positive, because a positive times a positive is positive, and a negative times a negative is positive again. So this bracket, because of the square, has to have an overall positive value regardless. And then here, you're only adding more. So if you've got a positive, and you're then adding another positive, no matter what x is, this expression is always greater than 0. If this had been a minus here, we couldn't have proven it like that. That will cross through somewhere. So it's only if this is a plus, basically, plus the final number, you're showing that that expression will always be positive. Then on a similar note, we can use this form to work out the turning points of the curve. So this would have also applied to the previous one. The turning point we get from the opposite side of this number. So if this is minus 2.5, this will be positive 2.5. And then this is just this number, so 2.75. If this is a turning point, if this is where the curve does this sort of thing, if this is above the x-axis, then yet again, that's just another proof that it's never going to cross it. It's always going to be positive. If we're okay with that, let's see how you get along on your own. So what I'd like you to do is take this quadratic here, so x squared minus 6x minus 8. First of all, put it in the completed square form, and then solve for x using that completed square form. Pause the video, have a go for yourself, and then when you're ready, press play again, and we can compare. So, putting this in the completed square form, so you're starting with your bracket, x. Now half of this is going to be minus 3 squared. Then you're going to minus the 3 squared, and then minus 8. So that's going to be a 9 here and an 8. So minus 9 minus 8 overall is minus 17. This is your completed square form. If we then want the values of x, when it cuts the x-axis, these solutions, we'll set that equal to 0. Move the 17 over. So x minus 3 squared equals 17. X minus 3, therefore, equals either plus or minus root, meaning x itself is going to be positive 3, because when you move the minus 3 over, the sign switches, plus or minus that root 17. If you got that, and you're happy to do so, let's look at an actual paper question. Here we have 2x squared plus 16x plus 35. Here is that example I mentioned before, where we're going to have an actual non-1 number in front of the x squared we're going to have to deal with differently. And we know we're going to have to deal with differently because, well, we've got our brackets that are squared plus a number afterwards. We've now also got this coefficient in front, this a value, and all a, b, and c are integers, they're all whole numbers. I've already said, though, that this completed square only works when the x squared is on its own. So we're going to have to factorise 2 out. Now, you can just factorise the 2 out of the first 2 terms, but I'm going to factorise out of everything just so we remember that we're everything that we're doing. So dividing 35 by 2 is going to leave you with 17.5. What's inside the bracket, we're now going to complete the square of. So we're then going to have bracket within a bracket, x plus 4 squared, and minus the 4 squared, plus 17.5. So that's just going to be x plus 4 squared. 4 squared, or 4 squared is 16, so minus 16 plus 17.5. That's going to leave us with plus 1.5. Finally then, just expanding out the big brackets, you're just left with 2 lots of the x plus 4 squared. Because the squared would happen first, that's what's going to affect this first, we can't times by the 2 yet. We can't bring that inside the bracket in any way. This is as best as we can write it. And that also then matches the form we're looking for at the top. And then just 2 times 1.5 is going to be 3. These are our numbers, and they are all integers. Then hence or otherwise, write down the coordinates of the turning point of the graph. Well, as said before, the turning point is the opposite sign of what's with x in the bracket. So here, our x coordinate of turning point is going to be minus 4. And then the y coordinate is just this final number here, as is, so it'll be 3. Again, just to clarify why that is the case, if this is the turning point, then this is going to be the minimum value the graph can have. In these cases, if it's a positive quadratic, it's got a positive x squared, the graph has to look like this. The turning point has to be a minimum. It's the lowest y value this can be. Because of this squared, if this had a negative value inside, it's just going to become positive again on the outside. The smallest value that this bracket, after being squared, can have is 0, because 0 squared is 0. Even if you went then just minus 1 squared is 1, we're already back to a bigger value. So basically, you want it to be whatever's in the bracket is 0 squared, and then again whatever came afterwards. The thing that makes the bracket equals 0 would be if x was minus 4. It's like when you're factorising. Okay, therefore, what's the solution? What x would make this bracket equal 0? So here, minus 4. And then if this bracket equals 0, the times 2 no longer makes a difference. 2 times 0, anything times 0 is 0. And then afterwards, you're left then with just a plus 3, which is why you then have that as your y coordinate. So turning point, what number is with the x in the bracket with the opposite sign? Y coordinate, just take what comes after.